The chain rule, section 1.7. What does the chain rule say? The chain rule is a rule to find derivatives of a given function, which is actually an extension of the power rule that we learned before. To start with the chain rule, we start by writing y equals f of x raised to any power m. If that's the given thing, how do you find y prime, the derivative of that? Well, we learned before that we bring m down, subtract from the exponent. But the chain rule said more than that, you multiply by the derivative of the inside. So this is what the chain rule is. What happened to the power rule? Well, if you have y equals x to the m, then y prime by the chain rule is m x m minus 1 times the derivative of the inside. But the derivative of x is 1. So times 1. So that gives me xm to the m minus 1. This is the power rule. That's what it is. So the power rule is a special case of the chain rule. And to work things out, let's say we have y equals x squared plus 1 to the third power. What is y prime? Y prime is 3 x squared plus 1 to the second power times the derivative of the inside, which is 2x. And then all I can do is multiply 2x by 3. That's 6x times, keep this the same. We can look at other examples. Say y equals x to the fourth plus 3x squared plus 5 all raised to the fourth power. Or y equals x squared plus 1 to the third times x squared minus 4 to the second. Let's see this one. Y prime is bring 4 down, x to the fourth plus 3x squared plus 5 to the third power times the derivative of the inside. Then keep this the same. X to the fourth plus 3x squared plus 5 to the third stays the same. The derivative of this one is 4x cubed plus 6x. Nothing needs to be done further than that. For the next one, we have two functions. When we apply the chain rule, we don't apply it to each one of them in that sense. I see a multiplication sign, so that reminds me of the product rule first. The product rule that we learned in previous section says you find the derivative of the first one. Like you copy them twice first if you like to think this way, with a plus sign. So you find the derivative of the first one and the derivative of the last one, like that. What do we get next? Y prime equals the derivative of this 3 down x squared plus 1 squared times the derivative of this by the chain rule, which is 2x. And keep this the same. Keep this the same. Derivative of this, bring the 2 down, subtract 1 from the exponent times the derivative of the inside. If we like to simplify more, the next step would be 2 times this, 3 times this, 6x, and this stays the same. You can multiply this and this, that's 4x and x squared plus 1 to the third times x squared minus 4 stays the same. So we try to multiply those small ones first, and then we need to simplify this by factoring. What can I factor here? The 6x and 4x, that's 2x common factoring. This one here and this, we take the x squared plus 1 squared, the smaller of them. This one and this one, we take the smaller, which is x squared minus 4. Then what is left? 3 x squared minus 4 plus 2 x squared plus 1. This is called the greatest common factor, the one I just took out. I'm going to keep it the same, and let's simplify inside the bracket. 3x squared minus 12 plus 2x squared plus 2. Y prime equals 2x, x squared plus 1 square, x squared minus 4, 5x squared minus 10. Another example, we need to find the derivative for, such as the square root of 3x plus 5. To find the derivative for this, it doesn't look like a function raised to some power, but we know if we have x, square root of x is the same as 1 over 2, x to the 1/2. We can rewrite it first, 3x plus 5 all to the 1/2. Now it's ready for derivative. We bring the 1/2 down, subtract 1 from the exponent, becomes negative 1/2 times the derivative of the inside, which is 3. Y prime equals, keep the 3 out, to bring this whole thing down. We can't have negative exponents in the final answers. No negative exponents. Another example, say negative 6x times 2 minus x to the 4th power. Well, the times reminds me of what? Of product rule. Product rule says take the first one, differentiate it, plus take the next one, second one here, and differentiate it. Let's see, derivative of this is negative 6, this stays the same, minus 6x, derivative of this, bring the 4 down, 2 minus x to the 3rd times the derivative of the inside. Y prime negative 6, 2 minus x to the 4th, plus 24x, 2 minus x to the 3rd. Among these, 6 is a common factor. We can take 2 minus x cubed as a common factor as well. What is left here is simply negative 1 plus 4x. And that's all we can get. So what actually we did here, we used the product rule and the chain rule at the same time within one problem. How about if we look at something slightly different? Let's say 3x squared plus 1 over 2x cubed plus 3 all squared. I see division. That reminds me of the quotient rule. Division reminds me of the quotient rule. So how am I going to find y prime for this? Quotient rule says you take the denominator times the numerator, like that, derivative, minus the numerator again, but derivative, times the numerator over the denominator all squared. Y prime equals, this stays the same. This one 6x minus 2 down, 2x squared plus 3 to the 1st power times 4x, 3x squared plus 1. Keep the denominator, multiply the 2 by 2, 4. What's y prime? these two, common factor is 2x. Also among these two, there's a cube here, there's a cube there. Among these two, take 2x cubed plus 3, and what is left, there's a 3 from there, and the 2x cubed plus 3 minus, we took the 2 out, the 2x cubed plus 3 is out, we have a 4 and x is out, 3x squared plus 1, and this stays the same. Y prime equals, we may reduce one copy from here, one copy from there, 2x cubed plus 3 all to the third power, 2x, and here 6x cubed plus 9 minus 12x squared minus 4. Y prime equals, keep this the same, 6x cubed minus 12x squared plus 5. Another example, say y equals 2x over x squared plus 1 to the third power. We need to find the derivative for this function. So to do so, this looks like f of x to some power. So the chain rule says you bring the 3 down, subtract 1 from the exponent, times the derivative of the inside, derivative of this. And how do we finish this up? Keep this the same, 2x over x squared plus 1 to the second, times, what's the derivative of this? Is the denominator times the derivative of the numerator minus the derivative of the denominator times the numerator, and the denominator square. Now the first half, nothing can be done to this, so we always copy it the same. This one, the derivative, so that's x squared plus 1 times 2 minus derivative of this is 2x times another 2x over x squared plus 1 square. 3 times, this stays the same, 2x squared plus 2 minus 4x squared divided by x squared plus 1 square. Y prime, keep this the same, 2 minus 2x squared all divided by x squared plus 1 square, and you may leave it like that, it's fine. As an application to this, find the equation of the tangent line. To the graph of y equals the square root of x squared plus 3x at 1, 2. So to find the equation of the line, that reminds me of y minus y1 equals m times x minus x1. So this is x1, y1. All I need is the slope. What is the slope? What does it equal to? We defined before the slope of the tangent line. It's the derivative of the function at the given x value, which is 1 at this value. So this means I need to find the derivative first for the given function, the x squared plus 3x, which I can rewrite as 1/2. Then y prime, bring the 1/2 down, subtract 1 from the exponent, times the derivative of this, which is 2x plus 3. Keep the 2x plus 3 on the top, 2, and bring that down, x squared plus 3x to the 1/2. when you take x equals 1, so y prime at x equals 1, 2 times 1 plus 3 over 2, 1 plus 3 to the 1/2. That gives me 5 over 2, 4 to the 1/2. 4 to the 1/2 is square root of 4, which is 2. So 2 times 2, 5 over 4. That's the slope. So the slope is 5 over 4. And the point that was given to us was 1, 2. As soon as I know the slope and the point, I can find the equation using y minus y1 equals m times x minus x1. So y minus 2 equals 5 over 4 x minus 1. And it would be best if we can write this final answer in the form y equals mx plus b. mx plus b. So y minus 2, multiply the 5 over 4. Then add 2 to both sides. Multiply by 4 by 4. 8 minus 5, 3 over 4. So that's what this section is about. It's about basically finding derivatives using the chain rule. The chain rule is a more general form of power rule. Power rule works only if the function is just x or not like something else. But the chain rule works no matter what the function is. And we saw how we applied this to finding the equation of a tangent line.